Okay, let's try to solve some linear trig equations. Okay, let me show you what I mean. Let's say you have sine of 2 theta is equal to root 3 over 2. How can I solve for theta in this case? And let's say we're told that theta is defined strictly to be between 0 and 2 pi. And the reason they have to tell you that is because technically you could have an infinite amount of answers for theta, because if you keep going around and around and around the circle, theta can be bigger and bigger and bigger, right? But it doesn't really change. You know how like 0 is the same as 360, right? And then that can be the same as 720, like it keeps growing, right? Every time you go around the circle. So theta could really be anything. So that's why it has to be defined like this. So they only want the answers of theta that fall into this range, okay? So with that in mind, let's go ahead and solve this. Okay, so what you would do is you would say sine of what angle is equal to root 3 over 2. So I would pull up my unit circle, and I would say where's root 3 over 2 as a y value, right? Because the sine value is becoming root 3 over 2. So you gotta look at the y values. So I start, 30 degrees, I look at those, I look at these ones, I look here, oh, here, root 3 over 2 is a y value, right? And that means that if I go over here, I should see it again, yep, root 3 over 2 is a y value here as well, because those both have the same height. So I have two possible answers, right? I have pi over 3, and I have 2 pi over 3. So pi over 3, and also 2 pi over 3, right? Those are both equal to this, because sine of that must equal that. So either 2 theta is equal to pi over 3, or 2 theta is equal to 2 pi over 3. And so in each case, you can solve for theta, right? Divide both sides by 2, you get theta equals pi over 6, and you get theta equals pi over 3. So those are your two answers. Okay, and that's it. Now, what if I want to solve a quadratic trig equation? And you're thinking, what's a quadratic trig equation? What is that? Well, let's look at this one. Let's say you have sine of x plus 1 times sine of x minus a half, and that's equal to 0. And we're going to be told again that x is defined as being between 0 and 2 pi, because again, we can't have infinite answers. So they define that, and they say, okay, solve for x. Okay, what do I do? Well, this kind of looks like a factored form for a quadratic, right? Right, a bracket times a bracket equals 0. So all you have to do is say, oh, well, if this bracket is 0, when you multiply it, it'll all become 0. Or when this bracket is 0, and then you multiply, it's all going to equal 0. So I can just set each of those brackets to 0 and solve for x, right? I can say sine x plus 1 is equal to 0, and I can say sine x minus a half is equal to 0, right? Okay, so what do we do now? Well, solve for x. So sine x equals negative 1, and sine x equals a half. So first what I have to do is figure out sine of what value, what angle, gives me negative 1. Well, you should remember that, right? That should be 270 degrees, or 3 pi over 2. Because sine negative 1 means you're at the bottom. That's the only case where you have a sine value of negative 1, okay? So for this case, x is equal to 3 pi over 2. Now over here, sine x equals a half. This one could be interesting. So where does sine of x equal a half? So you pull up the unit circle, we look for the sine value of 1/2. Pi over 6 has a sine value of 1/2. So x can equal pi over 6, and x can equal 5 pi over 6. So you get 3 answers for this one. Okay, let's do another example. Let's say you're told you have 6 cos squared x minus cos x minus 1 equals 0. And again, we're told that x has to be in between 0 and 2 pi. So what do? Well, what you can recognize is that this looks a lot like a quadratic in standard form, right? 6 times something squared minus that something minus 1, right? Pretend cos of x is just x, and this would look exactly like a quadratic. So what do? Well, we have to factor this to get it to look like the last example. And in order to factor this, we have to use decomposition. So the first number times the last number, 6 times negative 1 is negative 6. So I want two numbers that multiply to negative 6 and add to the middle number, which is negative 1. So it multiplies to negative 6 and adds to negative 1. I think negative 3 and 2 will work. So let's go ahead and decompose this. 6 cos squared x minus 3 cos x plus 2 cos x minus 1 equals 0. Common factor by grouping, right? Group the first two. You take out a 3 cos x, and you're left with 2 cos x minus 1. And then over here, you'll be left with 2 cos x minus 1 because there is no common factor, and that's equal to 0. Now we finish this off, you're going to get 3 cos x plus 1 times 2 cos x minus 1 is equal to 0. Now this looks a lot like the last question, and we can go ahead and solve for x. So we'll set each bracket to 0. 3 cos x plus 1 equals 0, and 2 cos x minus 1 equals 0. Solve for x in each case, bring the 1 to the other side. 3 cos x equals negative 1, divide by 3, cos x equals negative a third. And for this one, you'll get cos of x equals, bring over the 1, divide by 2, you'll get 1/2. So now I got to find where cos of x is equal to negative a third and 1/2 on the unit circle. So let's take a look. So negative a third, so that means I'm going to the left because we're talking about cos, right? That's your x direction. So where do I have negative 1/3? Well, it looks like negative 1/3 isn't really defined on here, right? So you can think about where negative a third would be. It would be like right around here, right? A third of the way to negative 1. So it's probably like up here somewhere, so less than 120 degrees, or 2 pi over 3, somewhere up there. And somewhere down here as well, you'll get two answers, but they're not defined on here. So to find them, we have to take the cos inverse of both sides, right? You have to say x is equal to cos inverse of negative a third, and we have to calculate this. If you calculate that, you're going to get x is equal to, approximately, because you're going to get a decimal here, 1.91. It's just shy of 2 pi over 3, right? And that makes sense because if you figure out what 2 pi over 3 is, 2 pi over 3 is just a little bit more than 2. So this is just a little bit shy of that, so that makes sense. But remember, we said we have another answer that has that same cos value, right? If you're thinking about it, that's your 1.91. You should have another one here because they have the same x value, right? They both go to the left the same amount. So if this here is your 1.91, you should also have this angle. Well, how do I find that? Well, all you have to do is say, okay, well, if I go all the way to here, that's pi, right? So if I find this difference here, I could add that to pi to get to the new angle. So if you do pi minus 1.91, that'll give me the difference here. Pi minus 1.91 is about 1.23. And then if you add that number to pi to get to this new one here, pi plus 1.23, you're going to get about 4.37. So that's your new x value, right? So you get 4.37 and 1.91, right? So this was 1.91. All the way to here is pi. So I wanted to find this angle in between those two. So I subtracted them, and I got 1.23. And if this angle and this one down here are the same, then this little related acute angle down here is also 1.23. So I did pi plus a 1.23 to get down here to the 4.37. That's how I got to that second angle. Okay, so you have to do a little bit of thinking there to figure that out. So just remember that oftentimes you will have two answers, and you have to find that second one. Okay, now up here, cos x equals 1/2. Well, we know what that is. If you're looking at a half for cos, that means we're coming to the right, and that means you're talking about pi over 3 and 5 pi over 3, right? They both have an x value of 1/2. So you get x equals pi over 3 and 5 pi over 3. So for this one, you get 4 different answers, right? These two are expressed using pi's. These two are rounded as decimals, but it doesn't matter, right? They're all radians. They're all angles, okay?